Today we're going to look at memory latency, and we're going to be measuring the memory latency on my laptop computer and see what we can learn about the way that memory is organized. So there are two goals. One is I want to show you how you can measure the effects of caching in the wild. This is basically a tool that would be very useful for you in the future when you're working with big clusters and so on. It is good to know how to actually measure the time, the clock time that it takes to perform various operations. Sometimes you do an operation, it takes 2 seconds, and then you do it another time and it takes 3 minutes, and you don't really know what the difference is. So it really helps to be able to measure things not in terms of how the spec is, like how do you measure them in clean situations, but how do they perform when working with your software and hardware. The second goal is to understand how to study long-tail distributions. Okay, so a lot of these distributions we're talking about here have long tails, and it requires some care to understand how to deal with those. So first, we're going to collect information about the system that is running. There is code that I'm skipping, which lets you find out the details of the specifications of your hardware. And so for my system here that I'm using, it's a MacBook Pro. It has an Intel 4-core CPU, and the clock rate is 2.5 gigahertz. So the important thing to notice is the different caches that you have, or the different levels of the memory hierarchy. There are two L1 caches, each one 32 kilobyte. Then you have one L2 cache that is 262 kilobyte, and then you have an L3 cache which is 6 megabytes. So you see that this cache is much bigger than this cache. This cache is really working at the clock speed of the system, and this cache is significantly slower. The next step is the main memory, which I have 17 gigabyte of memory. And then I have the solid-state disk that I'm using here, which is a 1 terabyte disk. So you see that you get bigger and bigger, but slower and slower. Okay, so we will look at this in detail in the following. Okay, so what is memory latency? It's basically the time difference between the time in which the CPU issues a read or a write command and the time that this command is complete. This time is very short when the element that you're dealing with is already in the L1 cache, and it is long if it is in external memory, disk or solid-state disk in my case. So we're going to look at different size blocks, and we're going to collect statistics for doing random memory access on these blocks. The first size block is 0, which is surprising. What do I mean by 0? I mean that it is useful when you do measurements that you also try to see what's the background. So what would it do if I basically don't do anything? What would the measurement show? Okay, so that helps you in the calibration, and you'll see that it is quite important here. The arrays will be either in memory or on the solid-state disk. What we're going to do is perform 100,000 for each one of these sizes and each one of the memory or disk. We're going to perform 100,000 read-write operations to random locations in the array. And then we're measuring the time it takes for each one of these operations. And then we're going to analyze